Okay, today we're going to talk about 8b, and particularly describing chemical reactions. We're going to do acid naming in class, and we're going to talk about describing chemical reactions. So I'm going to go ahead and scroll down here, get us to the slide that starts with chemical reactions. You probably may need to pause the video, take out a periodic table and your ion sheet, because we're going to be doing a lot of naming towards the end of this. Okay, so when we talk about chemical reactions, remember this is where a substance actually changes its identity. Okay, it's going to change its identity, and that's going to be, we're going to call what's there before, at the beginning, the reactants, what's there at the end, the products, and we're going to utilize the law of conservation of mass, meaning that whatever the mass we have of the reactants at the beginning, we're going to have the same mass of or the total mass of the products at the end, and that's going to help us what we're going to refer to as balancing chemical equations. Now, a chemical equation, we've seen them before, but they represent the identities in the amounts of reactants and products in chemical reactions. So this is what we're talking about right here. This 2 magnesiums plus 1 diatomic oxygen gives us 2 magnesium oxides, which is the reaction that we saw in the empirical formula lab. Oops, get this all organized. There we go. And this is just showing you the representative atoms. So you've got 2 magnesium atoms, 1 diatomic oxygen. They're going to react. They're going to rearrange themselves to get to the magnesium ion and the oxygen ion and form this ionic bond. So they're going to transfer some electrons that we'll come back to later. And it uses a lot of symbols and a lot of formulas. Now, if you remember, our indications that a chemical reaction took place include the production of heat or light, gas bubbles, means a gas is being created as a product, and we're going to see a lot of these reactions. A precipitate, which is the fancy term for a solid being generated, particularly from 2 liquids. So you start with 2 clear liquids. Well, it's tough to see here. When you combine them, you get a color change, which is part of the next option. But if you let this sit long enough, you're going to see this is actually a yellow solid that precipitates out of what we refer to as precipitating out of solution. And sometimes you get the color changes with a precipitate. Other times you'll get color changes with indicators that we'll talk about throughout the course of this semester. Now, for writing chemical equations, the number of atoms of each element must be the same on each side of the equation, the law of conservation of mass. So in other words, without even looking at the reaction, we should notice that we have 1, 2, 3, 4, 5, 6 bromines over here. We're going to have 1, 2, 3, 4, 5, 6 bromines over here, 2 aluminums and 2 aluminums. And the way that we can make them balance, we write all the formulas first. So we would have written diatomic bromine plus the aluminum gives us aluminum bromide. And then we would have gone back and balanced. Actually, I don't like this because we would have simplified this, but we go back and we balance them using coefficients. So I'm going to walk you through that process for several reactions during today's video. When we write chemical equations, most elements are written as just the elemental symbol. So if you have copper, it's going to be Cu, and it's going to be solid. If you have sodium, it's going to be Na as a solid. Now, diatomic molecules. This is where this really becomes important and why I had thrown this at you a few times, excuse me, over the course of the last couple of semesters. This is a molecule only containing 2 atoms. Hunkel fiber are all of the elements that are always found as diatomic elements, and it's something that we're going to have to remember when we're writing these reactions. There are a few other exceptions. Sulfur we have to find as S8. Okay, this is a picture of sulfur right up here. And phosphorus we find as P4. It just has to do with the arrangements of these atoms and why it's going to work better for them to be found that way, but it's just the way it is. All right, now word equations, that we just write out the names instead of the formulas. It's kind of the organizational process to make this a little bit easier to understand, and it just helps you write out the formula. So for example, if this is my description of my reaction, I have solid sodium oxide is added to water at room temperature and forms sodium hydroxide. Okay, that's the description. The word equation would simply be trying to figure out, okay, what are my reactants? So I took sodium oxide and added it to water. Okay, so those are both my reactants. They go over here on the left-hand side. My little arrow represents the fact that I'm going to switch to the other, switch to my products over here. That's the reaction is taking place. We've got the evidence. So we've got the reactants. We run the reaction, we get products. Then we write the formula equation, which is going to be taking these words and putting them into chemical symbols. So here's my formula for sodium oxide, my formula for water, my formula for sodium hydroxide. And then I have to go back and balance it. And that's where this 2 came from. Because if I have 2 sodiums over here, I gotta have 2 sodiums over here. So I put a 2 out in front, and that's gonna balance. That would balance the sodiums. Then I check the oxygens. Well, I have 2 of them over here. 1, 2. So that's gonna balance my oxygens. Last but not least, my hydrogens. I have 2 over here and 2 over here. So my hydrogens are balanced as well. Now here there are some symbols. When we have that arrow, it represents what we refer to as yields, or it separates the reactants and the products. This double-ended arrow is a reversible reaction, meaning it can go back the other way. And a lot of times above the arrow, if there's a delta sign, it means that we're actually to heat that reaction. Like when we ran the magnesium oxide lab, we would have had the fact that we actually heated it would have been a better indication of, more accurate way of writing that reaction. If we write something above the arrow, a lot of times that's a catalyst. So if I write manganese 4 oxide up above, that means that the manganese 4 oxide was there. It didn't participate in the reaction though. We put it in there to speed it up, and that's what a catalyst does. Okay. After the formula, you have to write the state that the substances are in. So this is where you're going to have S is going to stand for solid, L is going to stand for liquid, AQ is going to be aqueous or dissolved in water, G is going to be a gas. Now, when we say dissolved in water, this is also anytime it says we have a solution of something. Okay. Now again, for coefficients, these are the whole numbers out in front of the molecules. They specify the number of molecules in moles in a reaction. So again, here is the combustion of methane. Methane essentially is a coefficient of 1, so that means there's 1 molecule. You've got 2 for oxygen, 1 molecule of carbon dioxide, and 2 molecules of water. And again, we use that to balance the equation. Alright, so let's do some balancing. When we balance, you only can change the coefficients. You cannot change the subscripts. You cannot take water and make it H4O in order to balance the reaction. That's not going to work. Typically, I would say balance one type of atom at a time. Try to balance the polyatomics first. Don't forget your states. And I'm going to demo a lot of these, and we'll do lots of practice of this in class, and hopefully we'll be in good shape. Simplify it if you can, and always double check your work. Alright, let's do some samples. I have zinc metal. It's added to hydrochloric acid to create aqueous zinc chloride and hydrogen gas. Now, the word equation, I'm going to do a lot in the beginning. It really is just meant to help you organize what are your reactants and what are your products. Okay, so I've got zinc and hydrochloric acid. To create, you're going to see some word, combine, to form, generate, react to produce, but we get zinc chloride and hydrogen on the other side. Alright, now we got to write the formula equation in the balance, and I'm really going to do this all in one step. So my formula equation is going to be this. I have zinc, solid, and I know that's a solid because it's a metal at room temperature, and I'm going to react that with hydrochloric acid, which as we learned is going to be HCl, and all acids are aqueous. I think it may say this on the bottom here. Okay, all acids are aqueous, so whenever you see an acid, it's automatically aqueous. Now we have zinc chloride. To write the formula for zinc chloride, we have to go back to our ion charges. Zinc is Zn with a 2+, chloride is a 1-. So my formula for zinc chloride is ZnCl2. And then hydrogen is one of those diatomic elements, so I've got to write it as H2. Now, I'm not quite done because I got to make sure it's balanced. If I look at the zinc, there's 1 here, and there's 1 here. And some people will actually write out the numbers of atoms. I don't have to necessarily do it that way, but some people do. And whatever helps you, honestly, is what you need to do to be successful. So the zinc is balanced. Now if I go to the hydrogen, well, I have 2 hydrogens over here and 1 over here. So I'm going to go ahead and put a 2 in front of the hydrogen. And then if I look at the chlorines, so my hydrogens are now balanced. my chlorines, there's two of them in this reactant because the two distributes out across, and there's two over here. So I'm done. And that's my balanced chemical reaction for that reaction that we would see. Okay. Now another example, you've got solid calcium metal reacts with water to form aqueous calcium hydroxide and hydrogen gas. So again, what I've done here is your word equation to just organize where your reactants are and where your products. And some people are very easily going to be able to skip this step, but if you get confused as to what's what, take the time to write it out. It's going to make it easier. All right, so now if we write this reaction, I've got to start with my symbols. So I have calcium solid. I'm going to react it with water. Water is a liquid at room temperature. Then I'm going to have calcium hydroxide. Now again, that's an ionic compound. Calcium is a 2+, it's a group 2. I'm combining it with hydroxide, which is the 1-, it's a polyatomic. So my formula is going to be Ca with the OH in parentheses 2. And in terms of a state, it told me the state right here. It says aqueous calcium hydroxide. Remember, aqueous is going to mean solution. I'm going to put it underneath just so I don't run out of time or run out of space here. And then my last one is hydrogen gas. And remember, hydrogen's part of Hunkel fiber, so it's got to be a gas. Okay, or it's got to be H2 rather. All right, now to get it balanced, I'm going to start with the calcium. I've got 1 here and 1 here. So calcium has 1 and it's balanced. Hydrogen, I have 2 here and 2 here. So hydrogen's balanced. Again, I'm just writing the atoms up here just to show you some different strategies that work for different people. And then oxygen, no, I'm sorry, the hydrogen is not balanced. Let me go back for a second, and here's why. I have 2 hydrogens here and 2 hydrogens here, but wait, I have 2 more hydrogens over here. So in order to get this, the hydrogen balanced, I have to put a 2 in front of the water. So now I have 4 hydrogens on this side, and I have 1, 2, 3, 4 hydrogens on this side. Then last but not least, my oxygens. Well, I've got 2 oxygens here. I've got 2 oxygens there. So my oxygen is balanced with 2 as well. Okay, a couple more here. Next one we have is hydrogen peroxide in an aqueous solution, and it decomposes to produce oxygen and water. So again, here's the word equation, just designed to have you understand the reactants and the products. Now, hydrogen peroxide is one of those other formulas that we need to know. It's H2O2, and they told me that it was aqueous. So aqueous again is going to be AQ. It's going to wow, it's a little redundant on that one. It's going to decompose into oxygen, which is diatomic because it's part of Hunkel fiber, which is a gas, as well as water, which is liquid. And to get it balanced, I'm going to start with the hydrogens. Now, the hydrogens right now are balanced. 1, 2, 3, 4. And that's going to change here in a minute, because let's go to oxygens. Oxygen, I have 1, 2 over here. I have 1, 2, 3. Okay, that can't work. So I'm going to go ahead and put a 2, because I know the oxygen has to be even, because I can only come in pairs over here. So now I've got 1, 2, 3, 4 over here, and I'm going to put a 2 in front of the hydrogen peroxide in order to get it balanced. And if I come back to my hydrogens, well, I now have 1, 2, 3, 4. So hydrogen is balanced as well. And that's the final answer. That's my balanced chemical formula. And you can see this is really where the naming starts to become crucial. All right, let's do one more here. We've got copper and silver nitrate, and we're going to get solid copper metal reacts with aqueous silver nitrate to produce solid silver metal and aqueous copper 2 nitrate. Again, we've organized it into reactants and products. Let's go ahead and write our reaction. All right, we're going to have copper metal, copper solid, react that with silver nitrate, which is AgNO3, and this is going to be aqueous. Okay, they also told me that it's copper 2 nitrate on the other side, so I'm going to have silver solid, copper nitrate. Since it's copper 2, I've got to put a 2 here. This is what I meant about balancing the polyatomics first. If we have 2 nitrates here, I've got to put 2 nitrates here. Then I'm going to have to put a 2 in front of my silver, which is going to get my silvers balanced. My coppers are balanced. and I'm good to go. We'll do lots more in class. Hope that helps.